Lesson 6 is on partial variation. So we talked about direct variation in our last lesson. Now partial variation is a relationship between two variables in which the dependent variable is the sum of a constant number and a constant multiple of the independent variable. So we were using constant multiples in the last lesson. Now we're actually going to have a constant number as well that we need to add. So let's just look at example 1 so I can try and explain that. The graph below illustrates the total cost, C in dollars, of a taxi fare for a distance of d kilometers. So if you look at this graph, it's always interesting just to try and understand what the graph is saying. We have a certain distance in kilometers that we're going in a taxi, and then the cost of the taxi ride actually doesn't start at 0, it starts at $2. So how does this graph differ from one of direct variation? Well, the line for a direct variation has to start at 0. This line is starting up at $2. So we have this initial value here, which is making our line start up at a value other than 0. Why do you think the cost starts at $2? So imagine getting into a taxi. Usually there's already an amount that's showing up on the meter. You're already paying, I think it's maybe $3.50, $4, $5 before you even start to drive anywhere. So this is our initial cost for taking the taxi. And then determine how much it is per kilometer. So here we go again. Our constant of variation is how much for 1 kilometer. So that's not going to go away. That is our slope or our rate of change. How much is it for 1 kilometer? When we were doing direct variation, we could just look at something like, okay, it's $5 for 6 kilometers, and we could figure out our constant of variation from there. This is different though, because this line doesn't start at 0, it starts at 2. So if I was going to do that, I could do something like this maybe. I could look at, okay, if I come across this way, this would be from $2 to $5. So that's $3 for every 6 kilometers. Another way to look at it, we could look at here. I'm looking for some nice clear points. That's a difference of $1 for every 2 kilometers. So if we're trying to figure out how much it is for 1 kilometer, it's $3 for 6 kilometers. So I can divide those and I get 50 cents. So therefore the cost per kilometer is 50 cents. Write an equation to represent this information. So what we did in our last lesson, we were talking about these equations of lines, and there was this formula we had that was y equals mx. Now we actually have a constant of variation again. We know that it's our 50 cents. So the cost is 50 cents for every kilometer. So it could be 0.50, 50k, or d for distance. The difference is now, that's what we were doing on our last lesson. There's this initial cost though that we have to add to every kilometer. So we're going to have to say plus $2. So we have this initial fee. Our rate per kilometer still has a letter beside it. It has a variable beside it. This is our constant of variation, but now we also have an initial value. If we were going to sub in, let's say, 2 kilometers, how much would it cost to go 2 kilometers? Well, 50 cents times 2 is $1 plus another $2 initial fee. So to do 2 kilometers, go 2 kilometers, we have $3 from our graph. So this equation would work no matter what value we sub in for d. The distance traveled by taxi changes or is variable depending on the passenger's destination. We say that c varies partially with d. The graph of a partial variation is a straight line again that does not pass through the origin. So it starts somewhere above or below 0. So just a little summary here on the back. A direct variation from our last lesson starts at 0. A partial variation starts somewhere other than 0. So this is called our initial value. Okay, that's a fixed value. That's where our line starts. So when we look at our two different formulas, this is the one from our last lesson, y equals mx. is our formula because we just have a constant of variation or a slope or a rate. But I mean, I could write plus 0 here, but usually we wouldn't. That's the initial value. That's where the line starts. Writing plus 0 isn't really necessary. Over here, I'm going to have y equals mx plus b. This is my slope or my constant of variation, and then I also have to add in my initial value. So example 2, very different between direct and partial variation. Partial variation, you're going to see this extra value, this constant number that doesn't have a variable with it, it's just on its own. So identify each relation as direct variation, a partial variation, or neither. So lines, one thing you should know is that the largest exponent of a line should be 1. It needs to be a first degree equation. So we have y equals 3x. That would be direct variation because we don't have an initial value. When I look at the second example here, b, 2x plus 1, y equals 2x plus 1, there is our initial value. So this one would be partial. When I look at this one, it doesn't matter where the constant of variation is. It's over here this time because it has the variable with it. This is our initial value this time. Since we have an initial value of 500, this is partial. And this last one, we just have a constant of variation and no initial value. I know this is a rate or a constant of variation because it has a variable beside it. So this one is direct. So example 3, a small pizza costs $7 plus $1.50 per topping. So this is something that we could graph, but identify the fixed cost and the variable cost. So the fixed cost, how much does the pizza cost no matter what? So the pizza costs $7. That's just for the pizza. And then it's $1.50 per topping. So anything that is per topping, per one topping, that is our unit rate. And so that is our constant or variation or our slope. So we have a $7 fixed cost and we have a $1.50 variable cost. And why this is a variable cost is because it depends on how many toppings you get. If you get 2 toppings, this is actually $3. You could get 4 toppings or 5 toppings, right? If you don't get any toppings, then we would just have the fixed cost of the pizza, and the pizza would just cost $7. 1 topping, it would be, I guess, $8.50. So determine the equation relating cost and the number of toppings. So the cost of this pizza is $1.50 per topping. So we are going to need an N for number of toppings. The variables don't really matter to me at all, but $1.50 for every topping. That way, if I sub in 1 topping, I do $1.50 times 1. If I sub in 2 toppings, I do $1.50 times 2. Plus, we have the initial value of the pizza, and that's just the $7. So use the equation to determine the cost of a small pizza with 5 toppings. So that's why we write these equations in the first place. This is a partial variation because it has an initial fee here, an initial value. The reason we write these equations is because if I sub in 5 right there for that variable, so the 5 gets subbed in for the letter, $1.50 times 5 toppings, plus we can't forget to add the $7 for the pizza, original price of the pizza, $7.50 just for the toppings, and then $7 for the pizza. So in total, we're able to figure out that the pizza would cost $14.50.